Welcome to the course on microprocessor and microcontroller. So this course on microprocessor and microcontroller, I will be teaching about the architecture of a microprocessor, the instruction set used for giving some instructions to the microprocessor to do a particular task. Then I will be helping you to develop some applications. Coming to the second component of this course, the first component is the microprocessor. The second component is the microcontroller. So you will have a question whether the word microprocessor and microcontroller mean the same. Let me give you the explanation for what a microcontroller is. A microcontroller, let me write it here. It is a standalone system. Okay, it's a standalone computation system. So if I want to develop a particular application, okay, let us say I want to control the speed of electric motor in a washing machine, then I will go for a microcontroller IC, which I can use it for monitoring the speed of the electric motor, and based on various washing modes, I can instruct the electric motor to run at different speeds. So that's all about microcontroller. A microcontroller will have a central processing unit to do some task. Okay, so central processing unit is the heart of any electronic computation system. On the other hand, microprocessor, the name itself says it is a processing unit. Okay, so it's a processing unit. To develop a particular application, I need peripherals. So peripherals need to be interfaced with this microprocessor to do a task. Okay, let's take the example of a PC, a personal computer. In the personal computer, you will have a computer processor like the one you see in this picture. Okay, so this microprocessor or processor will be mounted on the motherboard. The motherboard will have other units interfaced like the random access memory, the graphics card, the keyboard, mouse, web camera, microphone, earphones. So whatever peripherals are required for interaction, all the peripherals will be interfaced with this microprocessor. So microprocessor cannot operate as a standalone computation system. Right? So that's the basic difference between a microprocessor and microcontroller. So with this basic idea, let's move forward. To understand this subject, so as a teacher, I have some prerequisites. The first prerequisite is the basic understanding of digital logic circuits. So this course under the Anna University Regulation 2017. So this course is delivered for the third year first semester students. So by now the students must have learnt a course called as digital logic circuits or digital electronics, in case the student is from some other engineering program. So the digital logic circuits or digital electronics, they must have learnt. So from digital logic circuits or digital electronics, a student must be able to use different number systems. So in this course, I will be using two number systems. So one is the binary number system. The next one is the hexadecimal number system. So I will be using these two number systems to demonstrate various processes. Next prerequisite is the logic gates. So here to demonstrate the architecture and the working of various components in an 8085 or a 8051 microcontroller, we will be using logic gates. Okay, so logic gates are the digital circuits which are involved in doing various tasks. So we will be learning about that. And the next requirement is the knowledge on flip-flops. So if you want to build any sequential system, it needs flip-flops. So if you want to build any sequential systems like a memory or a counter or even a register, you need flip-flops. So that is the fundamental module. Next is register. So register in microprocessor is used for storage. So the storage can be a permanent storage we have this read-only memory where some informations or instruction sets are stored forever. And then we have this memory device called as RAM, okay, the random access memory, okay, so for temporary access. Next is counters. So these are some prerequisites from the course digital logic circuits. Next is since this is a computation course, we are going to learn about an electronic computation system. Student must be familiar about writing a program. So ability to write a program using any programming language. So this is the prerequisite. Most of the students who are enrolled under regulation 2017 of Anna University must be familiar about Python programming. So that should do well here. Of course, the programming system which we are going to learn in this course will be an assembly level language. So Python is a high level language. So here we'll be using an assembly level language, and to understand assembly level language, I will also be teaching you the mission level language which is used for programming a computer. Moving forward, organization of this course. So this course comprises of two particular major modules. So one is the 8085 microprocessor, the other one is 8051 microcontroller. So we will start with the introduction of 8085 microprocessor. So in the first module, I will be teaching about the architecture. Architecture is the physical structure of a microprocessor. Then I will talk about the I/O ports. I/O ports are basically the pins, the output and input pins you find in an integrated circuits. So here specifically for 8085 we will be discussing. And then we will talk about the memory, okay, the two types of memory which you are already aware, the read-only memory and random access memory. Then I will talk about interrupts. Moving forward, I will be teaching about the assembly level programming concept of 8085 microprocessor. So this is somewhat close to a machine level language. This is not exactly a machine level language. So here in 8085 we will have something called as 8085 instruction set, which is actually a development made from the machine level language. Okay, whatever syntaxes which we are going to follow will be in a more understandable format. And after completing this, we will move on to the introduction of 8051 microcontroller, where again I will teach about the architecture, the pins, the memory devices and the interrupts. Moving forward, we will learn about the assembly level programming of 8051. So for a microcontroller, how to write a program. Okay. Then moving forward, I will enter the most important part of this course, the peripheral interfacing of microprocessor and microcontroller. If you want to build any application using a microprocessor or microcontroller, we need this peripherals, these I/O devices. This particular module will deliberate more on the I/O devices. Okay, I stands for input, O stands for output. Then finally coming to the application of 8051 microcontroller. So here, as per the syllabus, we will be discussing about some real-time examples like ATM machines, washing machines. So these are some examples which are given in the curriculum. Okay, so using these examples, we will try to understand how 8051 microcontroller is able to do some task. Okay, moving forward, evolution of computation. If you want to clearly understand what a microprocessor is or what a computation system does, then we have to start with the history of computers. So The history of computers, as you all know, it started in the year 500 BC. So there was one system called as abacus, which was invented in Babylonia. Okay, so the Babylonians invented this system. So this picture, which you find in the slide, shows a basic system of an abacus. Okay, so this is used for various arithmetic operation. So this is the beginning of computation system. Then after that, when the industrial revolution started, when many mechanical systems came into existence, Pascal invented a system called as the Pascal calculating machine in the year 1642. As you can see in this picture, there are some gears, there are some wheels here. So using this, arithmetic calculations were done. So if you take the calculator, the arithmetic calculator which was existing long back, the 1640s, 1650s, they were actually mechanical calculators. Then after this, vacuum tubes were invented. It was a big period. From 1940 to 1950, various vacuum tubes and vacuum tube relays were invented, and many electronic gadgets were fabricated using these vacuum tubes. And you will remember that the first computers were fabricated using these kind of vacuum tubes. Then, from the year 1960 onwards, the concept of integrated circuits came into existence. Okay, so even before this invention of integrated circuits, we had all the basic electronic components available in the market. Okay, so it was after the invention of the bipolar junction transistor, diodes. Okay, so when these discrete electronic components were available, later in the year 1960, people started integrating all these circuits under a single silicon piece, so which was later named as integrated circuit. So it is from integrated circuits the journey of microprocessor started. So what is a microprocessor? A microprocessor is basically a digital integrated circuit which are programmed to do a specific or desired task. So if you take the example of the calculator which we use for doing some calculation. So most of the engineering students will be having a scientific calculator to do various tasks, like doing some arithmetic operation, relational operation, even trigonometric functions, and the advanced calculators have the capability of even solving calculus, differential equation, okay, probability. There is no limitation these days. So those kind of systems, they have a central processing unit which we call it as microprocessor. So basically, it is a computation device. So after 1960s, after these integrated circuits came into picture, in the year 1971, Intel introduced the first microprocessor called as Intel 4004. So this microprocessor is a very primitive, it's a 4-bit microprocessor. Okay, it's a 4-bit microprocessor. So this picture will help you visualize what a microprocessor is. So this block, microprocessor, will have an arithmetic logic unit. It will have maybe a control unit. Okay, and you can see there is a memory block interface with this microprocessor. So what it means is, a microprocessor by default will have a system called as register. Okay, so these registers are again storage devices, but this register are meant only for temporary purpose. They are temporary registers. At the time of computation, these registers are deployed for doing a particular calculations. Let's take you want to add two numbers. Okay, say 4 plus 4. the answer is 8. So if you want this particular microprocessor to do this particular task, then the data, the data 4 and 4 has to be fed from the input device. So the input data will be given here. Okay, 4 and 4 will be given here. So once the data is fetched by the microprocessor, this data from the input device will be stored in the temporary register. So microprocessor by default will have storage mechanism, but it is only for temporary purpose. Okay. And the reason why we have a memory block here is if you want to store the answer, okay, let's say you are doing this addition operation and the answer you want to store it somewhere, then you need a memory. After performing the computation task, the answer will be loaded to the memory. Okay, so that is the reason why a memory device is very essential. And you can see the way memory device is connected to the microprocessor. I have used a bidirectional arm. So which means the microprocessor can both read and write data from the memory. Okay, and then you have the input devices and output devices. Say you are going to design a calculator, then the output of this addition process should be available in an LCD display. So LCD display is a peripheral. Okay, so this is all about the fundamental of a microprocessor. Now coming to the application. The picture which you see now is a photo of a motherboard of a particular personal computer. Okay, the green color electronic board which you find here is called as the motherboard. Okay, so motherboard has got many components which we will not be discussing today. And then the heart of this computer motherboard is this black color integrated circuit, and this is called as the microprocessor. Okay, so the microprocessor used here in this computer is an Intel. I don't know which model of microprocessor this should be, definitely more than the Pentium version of microprocessor. Fine. This semiconductor system is called as the RAM. Okay, in this picture you can see the heat sink. Okay, the heat sink is kept separately. So this picture will give you an wholesome idea that a microprocessor basically cannot do a task separately. So it needs the help of motherboard, it needs the help of RAM. Okay, it needs the help of I/O devices, it needs the help of an hard disk, okay, to do a particular task, right? And in today's scenario, whatever laptops, high performance laptops which we use, they have a microprocessor, and what you see here is a gaming console. Okay, even a gaming console, the heart of the gaming console is a microprocessor. Now moving on to the evolution of microprocessor. So in the beginning of this presentation, I started with the evolution of computation system. So here I am talking about the evolution of microprocessor. The evolution of integrated circuit started in the year 1960s, and after that 10 years later, in the year 1971, Intel manufactured first microprocessor called as Intel 4004. Okay, the technology used for this microprocessor is PMOS. When I was teaching the course on digital electronics, or maybe somewhere when you are learning this course, digital logic circuits or digital electronics during your second year, during the second year of your engineering program, you must have learned about a topic called as digital logic families. In digital logic families, you must have learned about various logic families like diode transistor logic, register transfer logic, transistor logic, CMOS logic, PMOS, NMOS logic. So this first generation of microprocessor was fabricated using this PMOS technology, okay, P channel MOSFET technology. Then moving on to the second generation. The second generation microprocessors came into existence in the year 1974, and the last one was available in the year 1978. So second generation microprocessor, it was fabricated using NMOS transistors. The reason why jump from PMOS to NMOS technology. So NMOS transistors were very faster than PMOS transistors. So the computation speed was more here. The Intel 8080, okay, the 8080 series, it was first fabricated using this NMOS transistor. Then the 8085 version, the 8086 version, and if you take the Motorola ICs, the 6800 version and 8088 versions were fabricated using the NMOS technology. To throw some more light on the characteristics of second generation microprocessor, the second generation microprocessor were bigger than the first generation. So this is one point which is worth to note. Okay, they were bigger. The chip size was bigger, so which means it can accommodate more number of digital circuitry. And this second generation microprocessor, they had 40 pins. Okay, the number of pins for 4004 transistor was very less. Okay, the 4-bit microprocessor had only 16 pins. The 4004 had only 16 pins. So which means most of the functionalities were multiplexed. So if you want to use those functionalities, you need a demultiplexer to use it. Okay. So this was bigger. It had the second generation microprocessor were bigger. It had 40 pins and it was faster. Okay. So in a nutshell, I can say this was more powerful those days when compared with the first generation microprocessor. Then moving on to the third generation of microprocessor. The third generation of microprocessor used a technology called as HMOS. So HMOS, it stands for high density MOSFET. Okay, I'll write it. High density MOSFET. So the meaning of high density is I can accommodate more number of transistors within a small area. So that is the meaning of high density MOSFET. So which means when you compare second generation and third generation microprocessor, a third generation microprocessor will have more functionality than a second generation because I can accommodate more circuits within a small area. Okay, so talking in terms of speed power product, third generation microprocessor were more powerful. Okay, so they were 4 times more powerful. 4 times more powerful than the predecessor. They were 4 times more powerful than the second generation microprocessor. Now coming to the fourth generation microprocessor. So it was between the year 1981 to 1985. They were using a technology called as HCMOS. So H stands for high density. The technology used was complementary MOSFETs. So till date we are using this CMOS technology for fabricating various digital circuits. To name a few microprocessors, we have the Intel 80386 and Motorola 68020, 68030 microprocessors. So one point worth noting here in fourth generation microprocessor is fourth generation supports floating point. Okay, so which means this floating point data type was not supported in the previous versions. Then moving on to the last timeline, that is from the year 1995 till the present date, that is called as the fifth generation of microprocessor. So fifth generation of microprocessor are the most powerful versions of microprocessors which are available these days. So on the picture you can see an Intel Pentium microprocessor and an AMD 64-bit Athlon microprocessor. So the computation speed of these microprocessor, they were very huge. And to give you a picture, so here I have stated that the Intel Pentium 4 microprocessor had 42 million transistors. Okay, so this talks about the density of this IC. So it supported 42 million transistors. So such a huge number of transistors were accommodated on a single integrated circuit. So any microprocessor released after 1995, you can claim it as fifth generation, and the operating speed were in the range of gigahertz. Okay. So with this, we come to an end of this session. So I would like to reiterate what was discussed. I started with the demonstration of what a microprocessor is and what a microcontroller is, and then I took you to the journey of computation system from the abacus till the present day electronic system. And then we try to understand the internal structure of a basic microprocessor unit. And finally, I concluded this session with the evolution of microprocessor. Thank you.